Now that we know how to simplify radicals, a number, now we're going to add some variables, making it a monomial. So we're going to simplify monomials. And just like numbers, variables can be simplified as well. So if m is a multiple of 2, use the rule square root am. You're going to use the rule a to the m over 2. Why are we using 2? Because we're going to be doing square roots. So think about this as you were taking this number and you were dividing it, m divided by 2. That's what we're doing here. If m is not a multiple of 2, break it apart. This kind of gets confusing, that rule, so I don't really want to talk about that one. So I want to show you the why behind here, okay? Now, my rule says it takes a group of 2 to come outside, okay? So I can apply the rule, remember it's a square root, so I can apply the rule, okay, x to the 2 over 2, and then I get x. That's my final answer, right? Because if I did this, and I did x squared, that means x times x, so a group of 2 comes outside, I'm left with x, and nothing is left underneath my radical. That's how we're getting that same answer. 2 different ways how to do it, right? I can even do it here. So here, my rule is m to the 6 divided by 2, because it's basically me taking that 2 and dividing it. So I get m to the 3rd is my answer. So if I had it listed underneath my radical, it would take 1, 2, 3 m's coming out, and I get m to the 3rd. I'm getting that same answer. But if I have m to the 100th power, I'm sure not going to write m 100 times. So all I'm going to do is take 100 divided by 2, and that's what gives me 50. So it would be m to the 50. Okay, numbers 3, you still have to simplify the square root of 9, and the square root of 9 is 3. And now I can do 2 divided by 2, which just gives me k. Because underneath this, if I expanded it, it would be 3 times 3 times k times k. A group of 3 came out, a group of k came out, leaving me 3k. Okay, I know square root of 64 off the top of my head is 8, and then I'm using the rule 4 divided by 2, and I get p squared, and that's my answer there. Number 5, square root of 100 is 10, and then 2 divided by 2 is just x, 2 divided by 2 is just y. So here's my final answer, 10xy. Over here, square root of 49 is 7, and then I'm going to divide all these by 2, and I get a, b to the 3rd, c squared. And that's my final answer. Now, here's what I want you to look at for number 7. I have an odd number. Okay? If I wrote this out, I would get y times y times y times y times y. Remember, it takes a group of 2 to come out because it's squared, so I'm going to take a y out. I took 2 y's out, which is y squared, and then left over, I have 1y. Now, let's take the same rule, 5 divided by 2. 2 goes into 5 2 whole times. That's why I'm getting the whole numbers outside. And the leftovers go underneath the radical. Okay, so we're going to do some more like that. Here we go over here. 2 divided by 2, I can take an a out. 2 goes into 3 1 whole time, so I can take 1 whole b out. But then I have a b left over. Let's jump down to number 9. And I'm going to divide all these by 2. So 2 goes into 2 1 whole time, so I can take 1x out. 2 goes into 3 1 whole time, so I can take 1 whole y, but then I've got a leftover y, because it's odd, I'm going to have leftovers. And then here I have 2 goes into 4 2 whole times, and I get z squared. Okay, so think about them. Your variables, they have to buddy up. If they don't have a buddy to go out with, they get stuck at home. They get left over underneath at home. You've got to have a buddy to go out. So here it would be 12 if I divided. 2 goes into 3 1 whole time, so I'm going to take 1k out, and left over I have k. Okay, now let's get to some that aren't perfect squares. So sometimes you're going to have a number like 15. I still have to do 60. Okay. Part 3 coming up.